Most teams think their AI is failing because they need a better model. They don't. The problem is your text, and the text is in your data catalog. Teams spend months evaluating embedding models, swapping one for another, tuning retrieval parameters, and still ship AI analysts that return confidently wrong answers. The model was never the bottleneck. What the model had to work with was. Here's what an embedding failure looks like in practice. An analyst asks your AI tool, what was last quarter's adjusted revenue, excluding APAC? The system searches your data estate, finds something that looks plausible, and returns an answer. Confidently, specifically, incorrectly. Because it retrieved the wrong table from the wrong team using the wrong definition of revenue. Nobody blames the embedding model when this happens. They blame the AI. They file a ticket, add a disclaimer, and keep testing. Teams describe this as testing hell. Weeks or months of evaluation where the AI gives different answers to the same question depending on how it's phrased. That instability is not a model problem. It's a retrieval problem. And retrieval is an embedding problem. And embeddings are, at their root, a data quality problem. The standard response when AI retrieval fails is to go deeper into the model layer. Try a different embedding model, add re-ranking, tune the chunk size, increase the number of retrieved passages. These are all legitimate techniques, and they all assume that the thing being embedded is already good enough, that the raw material is fine and the machinery needs adjustment. That assumption is reasonable if you're embedding clean, well-written documents. It doesn't hold when you're embedding enterprise data schemas. Enterprise data schemas aren't written for humans, let alone AI. Column names like rev underscore adjusted underscore Q4 carry meaning that lives entirely in someone's head or in a Slack message from 2021 or sadly, nowhere at all. When an embedding model reads that column name, it produces a vector that's semantically almost empty. Retrieval over those vectors is guesswork dressed up as precision. Now, the model isn't confused. It's working exactly as designed, faithfully encoding the absence of meaning in your metadata. Here's the reframe. Embeddings are not a model problem. They are a data quality problem. Specifically, they are a text quality problem. An embedding model converts text into a numerical representation, a vector, that encodes the meaning of that text. The richer and more precise the text, the richer and more precise the vector. The more semantically precise the vector, the more accurately retrieval matches a user's question to the right data set. Now, this isn't magic. It's the same principle as every other garbage in, garbage out problem in data, except the output is a number that silently determines whether your AI gives correct answers. What this means practically, teams that want better AI retrieval don't need better embedding models first. They need better text over their data assets, natural language descriptions, formally defined terms, documented ownership, certified meaning. Once that text exists, any competent embedding model will produce dramatically more precise vectors from it. One internal benchmark made this concrete. Propagating metadata, recency signals, quality score, schema context through every stage of a retrieval pipeline produced a 70% improvement in end-to-end answer quality and a 35 to 50% gain in retrieval recall. The model itself did not change. The input changed. This reframes what a governance program is for. Governed metadata, glossary terms attached to columns, certified descriptions, documented lineage is not just documentation infrastructure. It is the raw material of a functioning AI retrieval system. The teams building AI on top of a well-governed data estate aren't getting lucky. They have better embeddings because they have better text. Atlan produces the enriched text that embedding pipelines consume, not by replacing the pipeline, but by making the raw material precise before it enters one. Atlan's business glossary connects formal term definitions directly to data assets. When revenue is defined once in the glossary and linked to the columns that carry that concept, across every system, every downstream embedding of those columns inherits that precise semantic meaning. The divergence problem, where marketing's embedding of revenue and finance's embedding of revenue point to different things, is a glossary problem, and a governed glossary solves it structurally. For teams building at scale, Context Agent Studios coordinates a pipeline of specialist AI agents, a description agent, a README agent, a SQL intelligence agent. Each agent adds a layer of enrichment to data assets. The compounding effect is an asset profile so rich in semantic meaning that retrieval over those assets becomes reliably precise. The enriched text Atlan produces isn't locked into a proprietary store. It lives in Atlan's open, Iceberg native metadata lakehouse, queryable via SQL and accessible to any Iceberg REST compatible client. And it's pipeable directly into whatever embedding pipeline the team uses. The teams whose AI keeps returning wrong answers aren't running bad models. They're running good models over empty text. Every undocumented column, every undefined term, every schema name that only makes sense if you were in the room in 2021, those are not documentation debts. They are embedding deficits, and they compound silently every time a new AI use case is built on top of them. The teams that get this right treat governed metadata as the upstream investment that makes every AI initiative more accurate from the first query. Not because governance is virtuous, but because precision in the text layer is precision in the vector layer. And precision in the vector layer is the difference between an AI that returns confident answers and one that returns correct ones. Embeddings are a text quality problem, and text quality is a metadata problem. That means your governance program is actually your AI program. Once the retrieval layer is right, what does it take to build agents that can reason across that context, not just search it? That's what we cover next.